Some of you may remember the limbo dance craze, which asked the musical question, how low can you go? Well, one of the details you need to know to complete an instrument approach is flying's equivalent of how low can you go.
Psst, Rick, the hat.
What is the lowest altitude you can descend to if you don't see the runway environment? How low that altitude is may make the difference between breaking out of the clouds and landing or remaining in the clouds and making a missed approach. Now, with all the altitudes you see in the profile view, it might seem strange that you will not find the lowest altitude for the approach there. That's because one altitude won't normally cover all the possibilities for a particular approach. So you'll find a special, easy-to-read table just for the final altitudes, the landing minimums section. Here's a fine example. The landing minimum section for the VOR runway 14 approach at Hastings, Nebraska. Starting at the top left corner, you see the label category, which refers to the column headings across that top row. These are approach categories, and they're different than the ones used for pilot and aircraft certification. Approach categories are based on an aircraft's approach speed, and they're necessary for two good reasons. First, when you're flying faster, you have less time to see something and react to it. And second, your turn radius gets bigger as you increase your speed. This aircraft going slower will have a tighter turning radius. So, if an approach requires you to maneuver to line up with the runway, there must be a larger protected area for faster airplanes than for slower airplanes. There are 5 approach categories, A through E, although on most approaches you only see A through D. You find your airplane's approach category by first multiplying its VSO, which is stalling speed and landing configuration at maximum gross landing weight, by 1.3. Then you check that speed against the maneuvering table on page A1 in the front of the approach chart book. Category A covers 0 to 90 knots, Category B 91 to 120 knots, and so on. Category E, which covers speeds above 165 knots, would generally apply to military fighters or UFOs. Now, if you check the Pilot's Operating Handbook for your Cessna 172R, it has a VSO of 47 knots. Multiplying 1.3 times 47 equals 61 knots, which puts your Skyhawk comfortably within the 0 to 90 knot Category A. But if you're flying at a greater speed than 1.3 VSO, and that greater speed lies in the next higher approach category, you use the minimums under that higher category to make sure you have the appropriate obstruction clearance. For example, if you maneuver your Skyhawk at 95 knots during an approach, use the Category B minimums. Now let's look at the left-hand column below the category label, which is where you'll find the various ways you can fly the procedure on this chart. The first line, S14, tells you that this row contains the minimums for a straight-in landing to runway 14. The next line is labeled circling, for those situations when you don't want to land on runway 14 and choose to use another runway. So let's read across the straight-in runway 14 line and see what it tells you. Notice that there's only one set of numbers for both the Category A and Category B columns, and that's fairly common for straight-in approaches. The first number you see is in large bold font, and that's 2360. That's your minimum altitude MSL when you're flying this approach for a straight-in landing to runway 14. Its official title is Minimum Descent Altitude, or MDA. It's the lowest you may go until you're in a position to make a normal descent for landing. But what's that -1 following the MDA? The 1 is the visibility minimum. In this case, you must be able to see at least 1 statute mile in order to land safely from this approach. The next number, 399, isn't quite as important as the first two, and that's why it's in a little smaller font, but it still gives you valuable information. 399 in this example is your height above touchdown, or HAT. It refers to how high you'll be above the highest point in the first 3,000 feet of landing surface on runway 14 when you're at the MDA. In this case, you'd be 399 feet above the runway. So if the airport were reporting a 400-foot ceiling, being able to land on this approach would be pretty darn iffy. Now, unless you're flying in one of Uncle Sam's military organizations, you can ignore the set of figures in parentheses. Those numbers are how the minimums are expressed for military pilots. Let's take a look at how the minimums would change if you were flying something faster, say a Citation 10, and approaching at 125 knots, which would put you in Category C. The MDA is the same for Category C as Category A, but you would need an additional quarter mile of visibility for a total of 1 1/4 miles. Let's drop down now and look at the circling minimums. You see the same types of numbers here. It's just that they stack the MDA and visibility on top of the others instead of spreading them out on the same line. And that's because there's a separate set of minimums for each category. Notice that the MDA gets higher for each category as you move across. Faster airplanes require more room to maneuver, and apparently on this approach, that means higher obstructions in the maneuvering area. You can also see that the minimum visibility is higher for Category C and D aircraft, and that makes sense because of their higher speeds. Now, while the circling minimums format looks the same as the straight-in format, there is a difference in what one of the numbers means. These boxes for the circling minimums would get very cluttered if they tried to print a height above touchdown for each runway you might be circling to, especially at airports with lots of runways. So in the circling minimums, instead of HAT, you get height above airport, or HAA. Thus, for the Category A block in our example, the MDA of 2380 is 419 feet above the published airport elevation. After you've checked out the minimums, look for notes and symbols in the space below the table. As you already know, this T in the inverted triangle tells you the airport has a departure procedure or non-standard takeoff minimums for commercial operators or both. You'll find the details in the IFR Takeoff Minimums and Obstacle Departure Procedures section in the front of the approach chart book. You will commonly see notes about where to get your altimeter setting, like this one. It says, on the VOR DME approach to runway 3 at Pittsburgh, Kansas, use Joplin altimeter setting. Or you may see restrictions like this one. Straight-in minimums not authorized at night. And in case you're wondering, that's because runway 3 doesn't have any runway lights. The A in the triangle, followed by NA, tells you that you may not use this airport as an alternate when you're filing an IFR flight plan. We'll cover more details about alternates later. Now let's take a look at the minimums section of the VOR runway 12 approach at McCook, Nebraska, where you'll find a second table labeled DME minimums. Since DME isn't in the approach name, you don't have to have DME to fly the approach. But without DME, your MDA would be 3,200 feet. If, on the other hand, you do have DME or an approved substitute and you can identify the 2.6 DME fix, you may use the lower minimums in that second table. That lets you descend to 3,000 feet, and that difference of 200 feet might be just enough to let you get in when the weather's a little nasty. Although Jeppesen arranges the minimums table a little differently, you shouldn't have any trouble finding the data. The categories are listed down the left side instead of across the top. The conditions are across the top with straight in on the left and circling on the right. Notice that the two straight in MDAs mirror what you saw on the NOS version. They put notations with D2.6 and without D2.6 just under each MDA. The D, of course, stands for DME. But look further down into the blocks for categories A and B, and you see both a 3/4 mile and a 1 mile visibility for each of the two straight-in MDAs. The higher 1 mile minimum on the right of each is under a note that says ALS out. That means you need more visibility to land safely when the approach light system isn't working. That greater visibility amounts to applying a penalty to the minimums when all the components of the approach, like approach lights, aren't there. In the NOS charts, you have to consult a table in the front of the book to see how much to raise the minimums when a component is out of service. We'll talk more later about how to deal with inoperative components. Finally, in case you haven't memorized the airspeed brackets for the approach categories, Jeppesen prints the maximum for each in the circle to land part of the table. Well, our discussion on landing minimums may not have answered the musical question, how low can you go? That's pretty low. But if you check the landing minimum section on your approach plate, you'll always know how low you can go on an approach.